Hi, so welcome on this basically tutorial on how to use Foundry. The main goal here is to explain, like for beginners mainly, how to write, test, and deploy your smart contracts using Foundry. So Foundry is a framework that helps you to write your contracts, to test it, to build it, and everything around it. There is like useful functions that can be used to write your test and make sure that everything works as intended. And we're going to try to cover them to make sure that the next time you're writing a contract, you can find issues and deploy it the nice way. So to write smart contracts, we're going to start with the very basics. You should follow the best code standards, which most of the time are from OpenZeppelin, which if you don't know them, it's like a very famous company that's writing a lot of the basic smart contracts that you use to inherit from them and then write whatever you want. So you should follow their guidelines. It basically explains how to write good code. And it will be used later if other people than you needs to read the contract, to then make changes or find bugs. It will be really useful if it's written the right way so that everyone can understand it. Another tip is to always use trusted libraries. So for example, OpenZeppelin, Solid or Soulmate should be used instead of redefining everything from scratch. And to install them on Foundry, you can just use forge install, the account and the repo, and it will just work fine. So we're going to start with a very simple smart contract they call Workshop. It's basically a contract that allows you to mint a token if you pay for a certain price. The price is just given here, it's like an example. I made a max supply and gave it, the precision is to make sure in Solidity, you don't have float divisions, and you have to do only integer divisions, so that's why precisions are there. Then there are the events. I put them here to make the contract a bit smaller, but if you follow the guidelines, you should have them in the interface. Sorry. This contract, so it inherits from an ERC20, which is the most common contract. It's a token, a fungible token, which can be used to here in our example, you will give IVAX to receive this token depending on how much you sent. So those are the only function of the contract. It allows you to mint some token and to burn some token to receive the amount that you paid. This contract has two main issues, and we're going to find out them later using tests. That's the goal of this example, but maybe you can already find the issue. So we're going to go over them quickly, just in case you are not familiar. So you have the mint function. You specify to who you want to mint them and the amount. You verify that the amount is less than the max supply. And you also verify that the amount times the price is the value that is sent, so that the price that you wanted for your token is actually the price sent by the user. You then mint the tokens and then emit the event. And for the burn function, it's the same thing, but reverse. You destroy the tokens, and you send back the value that the user sent. Does anyone can see any issue in these contracts already, or not yet? Yes?
There's no check for circulating supply plus amount.
Exactly. That's one of probably the most obvious issue. Here, the amount, it's just the amount. So what you minted earlier, it's exactly what you said, it's not checked. So you can mint like max supply 2 times. You are effectively increase the supply more than what was expected, and it will just work fine. We'll see later how we could have found this issue using tests. And does anyone can see the other issue maybe? It's a bit trickier. Not yet? Okay, let's skip and go back later then. So when you write smart contracts, to then test them, it's very important to have your foundry.toml, which is like the options of Foundry, ready and made the right way. So you have the remappings that allows you to say to Foundry where are the contracts that you are using. So for example, the OpenZeppelin contracts, I'm saying they are in the library folders. Then I set the RPC so that I can interact with it instead of just putting the entire URL. I can just use the acronym Avalanche or Fuji. And EtherScan is to then verify the contract, because it's pretty important to verify your contract so that user can make sure that what they are interacting with is safe and it's what they intended to. So testing your smart contracts now. You're right. You wrote the previous contract. There are some issues, but you only found one. And now let's see how you could have found one, but also the most tricky one, using tests. So smart contract should be tested, and coverage should be close to 100%, but it's not the truth. Even if your contract is tested at 100% coverage, doesn't mean it doesn't have bug, and we'll see that later. And you can actually check the coverage just using forge coverage for the command, sorry. Tests are written in solidity, which is very handy, because when you do tests, then you can reuse parts of that to then write interactions or other contracts like a router, for example. And the function should always start with test. So it can be test, mint, test, burn, or whatever. As I said, unit tests are not enough. Sometime it will be. You will find the most obvious issues and the one like when you made a typo or inverted like the plus or minus sign or stuff like that. But you should use fuzzing, and sometimes you can also use invariant testing, but we won't cover invariant testing right now because it's a bit too complex, and or else this session would be way too long. And you can actually run the test just by using forge test, with this little acronym to say this is the verbose, and this will try to put as many explanations when a test fails with the stack. So it will go over everything it did, to try to explain what happened, and then you can read the stack to understand what happened wrong. To write tests, you have to import the test from Forge. You import your contract, so it's named bad because it's a bad contract. Oh, by the way, I forgot to mention this. All those contracts and everything can be found using this QR code. So you, if you want to write tests, you basically always use this format, which is naming your contract, inheriting the test, having your variables. This is just workshop, because that's the one I want to deploy. I create two users, which is Alice and Bob, which is like most of the time you name them that way. I redefine the two events is to later on test that the events are emitted correctly. And this is the part where you set up the test contract. So you have to deploy your workshop, and then I transfer some IVACs to my users that I created to then be able to interact with it. To test, we're going to try to test the min function first. So as I said earlier, you have to write the first word of the function name should be test something, and the best way is to always name it something that is easy to read. So here, test min, because I'm going to test the min function. And when you want to verify something, you use the assert ek or greater than equal, or there is other like variation of that. And what I would suggest is to always name the return as the name of the function plus the iteration of where it happened. So it's 1, 2, 3. So that if it reverts here, if you didn't put that, it would just say, okay, this test failed, but you don't know how or when or where. And by just adding those little name, it will say, okay, it reverted with this error, and so you know it's because of that, for example. Something useful is the prank command. It allows you to send the call as if you were Alice. So it's very useful to test, for example, if you have an owner, to test that the owner can do something and that Alice or Bob can't do that thing that the owner can. Here we are checking that the event is emitted the right way, so that it's Alice that is sending the amount, that Alice is receiving the amount, and the amount is the one expected. Sometimes the event is emitted wrongly and can be an issue later on when you want to build an indexer or for third party that actually use those events to update the state of your contracts. So here we are just minting 10, then 20. This function will work just fine. Then you want to test the revert version, so when you exceed the max supply. But here I did it in a way so that you're actually minting more than the supply wants, just so that you see that unit testing sometimes is not enough. But if you have done it, if you did it in two ways, you would have seen that it wouldn't have exceeded. We'll see that later on. And then you want to verify that the way it reverts is the way expected, so with the error that was earlier chosen, with evenly the amount for when it's not the right amount. Same thing for burn. We're not going to cover that, or it will be a bit too long. and revert. And what is important is that if you actually try these tests, they will all pass without any errors. But we've seen that there is at least one error that you point out with the supply, and that's why unit tests, sometimes they are not enough. Here we're going to see how to do fuzz tests, which are randomized inputs on a contract to try to mimic what would happen in a real-life scenario, so when actual users use your protocols. So we are going to use two amounts, min0 and min1. Here we are making sure that the min0 is less than the max amount, and we later on use the mint1, where it's set. Oh, here. Mint1, it's up to the max amount again. When you run this test, it will actually fail because of what we said earlier. You can mint more than the max supply if mint is two times more than the max amount. But I mean, if mint0 plus mint1 is greater than max amount, then it will fail at that time. But before, we didn't catch that, which is the first issue. And a second issue that this test will catch is at the end of minting 0 and mint1, we verify that the amount that is actually minted has the expected price, which is price times minted divided by the precision. But the issue is that earlier, I'm going to go back with the mint function. Here, you're actually rounding down. In Solidity, as it's integer division, you're always rounding down when doing division. So if this result is not exact, and it's, for example, 1.1, it will be rounded to 1, and that's it. So what an attacker can do is he can mint some token so that this amount is rounded down. So it can even be rounded to 0. Like if you say 1 here, 1 times the price divided by precision, it will actually be 0, but you will actually mint tokens. So you can mint yourself a bunch of tokens and then burn them later on. But the amount will be the sum that you put in. So even if here it rounded down, here it might be an exact division where it won't round down. So you can actually extract money out of this contract. And that's the second issue that is a bit trickier to catch. And without actual fuzz testing, you might have forgot to check this one. And how to fix it? Sorry, it's basically to just round up. You can't round up by default on Solidity, so you have to make some tricks. So I divided by b plus the modulus of the division if it's 0. So if the remainder of that division is 0, then you add nothing. And if it's 1.1, then you round up to 2. Because you should always round against your users to make sure that your contract is not insolvent. Let's go back to the first test. So yeah, this test will catch actually the two issues, and that's how you can find them. Foundry will give you, when the test will revert, as you put the verbose at 3, when a test reverts, Foundry will give you the stack, and you can, by trying to find how it happened, then fix it, basically. What's that? Never mind. I think that's another way to catch the same issue with the max supply. Oh yeah, no, I mean, the previous didn't catch this one. So this one is just checking that you are minting an amount, then you mint that amount plus 1, like the max amount plus 1 that is remaining, and it won't actually revert, and that's how you catch the first issue. Then when your contract is tested and you make sure that everything is fine, you need to deploy your smart contract. They should always be deployed using scripts. It's way safer because you can deploy a bunch of them simultaneously and to actually test that the deployment was successful and that it was as expected. The scripts are also written in Solidity, and they should always be name run. And then there is only one per file. So if you want to do multiple deploy scripts, you have to do multiple deploy files. Your contracts should be verified on the main explorer, as we said earlier. That's why it's important to set your foundry.toml correctly, because then you can just run your script using this command with the verify, and it will do everything for you. You won't have to do to verify it yourself, which can be painful sometimes. This is an example to actually deploy the workshop contract. So it's quite easy. You do the same idea of the test, but this time you take the script framework from Foundry. Then you take your contract, which is the fixed one, because you don't want to deploy the wrong one. You inherit from the script. The setup function is to create like what would happen before the actual execution. So what we want to do is to go to Fuji. Fuji is the testnet of Avalanche. And then it will run the run function, which will actually take the private key of my deployer. Broadcast is the code to actually use the private key that I give here to do an action. So here it will broadcast the fact to deploy this contract. I already deployed them to make sure that it works in case the Wi-Fi or something is not good enough. So this should be what you have at the end. This is on testnet.snowtrace.xyz, where if you put the right address, you can find that this contract is actually deployed. The little green checkmark says that the contract is verified, so you can actually interact with it with ease, and that it just worked fine as you expected. When you interact with your smart contracts, it should be done like using a front end or something like that. But if you want to do some owner like settings and stuff like that, you should interact with them using script as well. But this time it's like interaction scripts. It's the same idea. You have to name them run, and you run them the same way, but you don't have to verify them because it's not a deployment this time. And for example, this is an interaction script to actually mint tokens. So you just want to receive 10 of those tokens to send that value. And by broadcasting again, you will be able to mint those tokens. This is the example of the success. You can see that I actually minted to my account those 10 tokens for 0.09 VAX, and everything went well. But this is not always the case, and sometimes your interaction or something will happen, and your contract will revert. And it's actually pretty hard to debug a failed transaction. That's why we want to rerun them using Forge. You can also use tenderly, but here we are not just talking about Forge and Foundry, so we're not going to talk about that, but this is also a useful tool. And to rerun a failed transaction, you use cast run, the transaction hash, and the RPC URL. So this is a failed transaction. As you can see on the Explorer, you have no information. You know that I called mint, that it failed somehow, somewhere, and it just reverted. But you have no idea what happens. And it can be very hard to actually know what happened and to debug it. So you have to use Foundry, you should be, or tenderly. And by using the command given earlier, you can see that this will give you the stack trace. So this is what happened. I called my workshop contract with the mint function. I cut the rest because it was too big, but it's just like the value and the amount that I wanted to mint. And you have the actual revert reason. It reverted with invalid amount. You go to your contract and you check what is invalid amount. That's that. So it means that I didn't give enough, or I gave too much AVAX for the amount that I gave. And this will happen like quite often, that someone says that your contract like have an issue or something like that. If they have a failed transaction, it's actually very easy to debug it using the cast run function. And so if you have issues, sometimes it's actually better to send the failed transaction to then rerun it later to make sure it works. Or you can do a test, as we've seen earlier. It will give you the same stack trace, but sometimes it's a bit just easier to have a failed transaction. As Avalanche is pretty cheap, it's not a big deal. And now we can see the last really useful function is the selectors list, especially if you use custom custom errors, sorry. It will revert with a selector. And those selectors, sometimes always, you have no idea what this means. This will give you the actual list of all the functions, all the errors, and all the events from the name to their selectors. So you can just check that table to see what happened to your contract. And what can be useful as well is to upload them to, I think it's openchain.xyz, that is used by basically all RPCs and all block explorers to actually decode the selector to the name. So when you see on the Explorer that it called mint, in fact, if my contract was not, the selector was not verified, it would not show mint, it would show like OX or IBCDE or something like that, and you have even less idea what happened. So it's kind of important to upload your selectors to make sure that the block explorers and when you use the stack trace as well, decode your function the right way, so it's way easier for you to debug and everything. And that's basically it. If you have any question, feel free to ask them. But thanks you for your attention. And yes?
I noticed in the config Thank you. In the beginning, you showed us the config for Forge, and we defined, we configured everything to be, let's say, routed to Fuji. So I guess, I guess we can, in the same manner, point to our own L1 on Fuji.
Yes, exactly. Like, if it was another network, you could. Thank you. If it was another network, you would just use your own RPC endpoint here. So it could be, I don't know, localhost if you're testing, or your actual RPC. It can be any chain as well. It can be Ethereum, Arbitrum. You just put your RPC endpoint, and Etherscan, if you have a block explorer, you just put the URL of the block explorer. And if you have a key, sometimes you don't need a key, so you can just leave that blank. But that's how you will make sure that when you do your, this is useful for your tests. Not this one, no, for your scripts, sorry. Where are they? Let's just as if one. You can just input Fuji instead of the all URL, which can be painful, especially if you're using like a paid RPC where you have a private key and you need to put that there. That's a bit not a good idea. So you use that way. And the Etherscan is for the deploy script actually, to when you use those verify, it tries to verify the contract the right way. And if you used an RPC that needed a key, or like a block explorer, but I don't think block explorer, they have their key here, you can just put the slash here with your, the same that is there, with the $sign and the name of the key. Does anyone have another question maybe? Okay, thank you.